I'm going to be speaking about Newton's 3 laws of physics, and this is so important that he even had his own unit of force named after him, the Newton. Now let's go in this step by step, as there are 3 steps, and you should memorize these. You'll happen to see that you see these in everyday lives. For instance, your first law of motion, you might see when pushing a heavy object, but without further ado, let's begin our lesson. The first law of motion is considered the law of inertia. Well, why is it considered the law of inertia? Because inertia is the tendency for an object to resist motion. Right? Let me write this down. In blue, no, sorry about that. In blue, our first law would be inertia. So whenever somebody says inertia, remember Isaac Newton's first law. And so essentially, what is inertia, you might ask? And simply, inertia is simply the tendency of an object to resist motion. And what I mean by that is that in heavier, or the more mass an object has, I should say, the more inertia it will have. Can you give me an example of this? Sure. Well, if we have a light can of soda, let's envision this is soda, then we're going to apply a little bit of force, and it will move relatively easily. But what if we have a very large box of books? Well, that means it's going to take much more force to push it. And it's saying that these objects under inertia will not want to change their motion. These are at rest, and they want to stay at rest. And the more mass it has, the more predictability it will have to resist this motion. Well, the first law, we might consider this in terms of words as simply, or not simply at all, an object at rest will remain in rest, and an object at motion will remain in motion unless acted upon by an unbalanced force. See, this unbalanced force in this case will be these arrows, or your hand as it pushes the soda can and the book. Now let's advance onto the second law. The first law was relatively easy, wasn't it? The second law of motion is an equation. The second law, the equation is, you might have heard it before, the equation is force is mass times acceleration. And why is this a law, you might say? Well, I think it might be the most significant of these laws. Why? Well, because it states that mass resists acceleration. And so, the less mass you will have, the more acceleration you'll have. Let me give you an example of what I mean. Like I did in the previous example, we'll have a baseball. Envision this is a baseball, of course. Envision this is a baseball. And we might have something that's heavy. Let's envision this as something that's heavy. This baseball is obviously much less massive than this heavy stuff or thing. And so obviously it's going to have bigger acceleration. And this is why I love history. I mean, physics so much. I do love history, but physics as well. I love physics because it says that it models things that we see in everyday life through mathematical and scientific explanations. To calculate this equation, force equals mass times acceleration, we might want to have a quantity of a mass. So that would be in kilograms. We'll have, say, 2 kilograms. And our acceleration might be, for simplicity's sake, 1 meter per second squared. And once we're given these two values, we simply multiply as force equals mass times acceleration. 2 times 1, as we know, is 2. And we can write down kilograms times meter per second squared. However, here's a catch. This is often not the way it's written. We're usually going to see, this is supposed to be multiplication, so let's just cross this out in general. We might see newtons instead. And this is what I prefer. I like to say newtons because kilograms times meters per second squared is kind of hard to say, and it's a mouthful. Regardless, moving on, we're going to go to the third law of motion. The third law of motion is the famous saying, for every action, there is an equal and opposite reaction. Well, what does this mean? You hear it all the time regarding business, well, health, everything, it revolves around this saying, and it's not a scientific principle they use, but right now we're going to use it to explain the physical world. Well, I'm going to give you an example by this first, like I did in the previous ones. Let's say here's Bob. He's on the ground and he wants to walk. Well, what does Bob have to do to walk? He has to exert force on this ground, and this ground will apply an equal force. Let me draw something like this. God, I'm having problems with colors today. Equal force, and this Bob, which probably now you cannot see, but he's here, he will be able to walk, and this sensation, equal and opposite reaction, will create something that will resemble motion, and this is how essentially you walk. Fascinating, isn't it? Well, what I want to leave you in this video is how we can apply these Newton's 3 laws of motion in our everyday lives. Newton's 3 laws of motion were extremely crucial to the way we live today. And what I want you to do is, maybe when you're walking downstairs to get a soda or a drink or any kind of thing you want in general, I want you to model the things that you see. You might see force equals mass times acceleration, second law, when you're trying to throw the tennis ball to your dog, or inertia, when you're trying to move a heavy chair out of the way so you can open the door, or you might see third law of motion, when you're simply walking to do those things. See you in the next one.